Today I'm going to be talking about analyzing graphs of polynomial functions. This is Chapter 5, Section 8. So first of all, we need to graph this function. If we look at it, it's in intercept form, so we can use these intercepts or these zeros to start making this graph. So we're going to use our intercepts. So my x-intercepts here are going to be -2, 0, 1, 0, and 3, 0. And I can graph these on here. All right, the next thing is we're going to use a table of values to find the points in between these zeros and 1 beyond and after. So 2 points beyond. So I'm going to write my table of values, and I'm going to use the points -3, -1, 0, 2, and 4. So I'm going to use those that go in between our zeros and beyond them. So I get a -6, 2, 1.5, -1, and 4.5. And I'm going to graph those. So I have a -3, -6, -1, 2, 0, 1.5, 2, -1, and 4, 4.5. Okay? And the last piece is the end behavior. Since we have 3 zeros, that means the degree is 3, so the degree is odd, and our leading coefficient of 1/4 is positive. So our end behavior looks something like that. So we can use that end behavior to graph this. And then we are going to make our nice curve and go back upwards using our end behavior. So that's how you graph your function in your intercept form. Next, what we're going to do is we're going to graph this function, identify the x-intercepts and the points where the local maximums and local minimums occur. Then we're going to determine the intervals for which the function is increasing or decreasing. Now with this one, we can actually use our graphing calculator to graph this and find all these pieces of information. So I'm going to go to my graphing calculator, and in my y equals, I'm going to put in my function, -x to the 4th plus 3x. I'm going to graph. Okay? Make sure your window is set correctly. So I'm going to go back to my zoom standard. There we go. And now it should graph. So now what we're going to do is we're going to find our x-intercepts using our second trace function, and we go to 0, or number 2, to find our zeros. And this is where we go left bound, then right bound, then enter. And so our first 0 is at 0, 0. That's our first intercept. Our next intercept, we're going to second trace again, and then go to number 2 for our 0. We're going to select our left bound, our right bound, and then enter. And we want to round to the nearest hundredth, so this is going to be 1.440 for our x-intercept. So we're going to write those down. We have 0, 0. We have 1.440. And we're going to graph those on here. Okay. Next, we have to find our local maximum and our local minimums. Now, our local maximum and minimums are at our turning points. And for this one, we only have one turning point, and that's a local maximum. So what we're going to do is we're going to use our second trace feature. We're going to go to number 4 for our maximum, do our left bound, our right bound, and then enter. And this one is going to be about 0.91 to 0.04. So let's write that down. We have a local maximum, which is at 0.91 and 2.04. We do not have a local minimum. So we can graph this about 0.91, 2.04, about here. And we can sketch it out just like that. So using this, we can find where our function is increasing or decreasing. And wherever we're increasing or decreasing, we're going to use our local maximums and minimums, our x values. So this function is increasing where x is less than 0.91. So right here, from here to here, it's increasing. For decreasing from here to here, it's going to be where x is greater than 0.91. So those are all your pieces. You can use your graphing calculator to find your intercepts, your maximums, your minimums, and then you look at your graph to find your increasing or decreasing. All right, our next one, we can look at a graph to estimate these points, So it says estimate the coordinates of each turning point, state whether each corresponds to a local maximum or a local minimum, then estimate the real zeros and find the least possible degree of the function. So if we take a look at this, we have to write down our turning points. And we're just going to estimate those turning points. So we're going to estimate this point and this point right here. Okay? So we have one at about -3, -1, and another one about 1, -6.5. So those are our turning points. And they wanted to see if they're local minimums or maximums. Well, our -3, -1 is a local max. And our 1 at -6.5 is our local min. Okay? Now, this next part, we have to figure out the least possible degree of the function. If we look, we only have one real zero right here. But obviously this is not a linear, it's not a quadratic. So the next least possible degree could be a cubic.